Okay, now let's take a look at number 4. Number 4 is a bit involved, and there are actually two methods to solve. So as you can see, we are given two different forms, but we're being told that this thing is the same quadratic function. So I have two different forms for the same parabola, and this question is just about getting us to solve for the parameters a, b, and c. I'm going to do this question two ways. Method 1 is what I want to describe as sort of the brute force method. Okay, and what we can always do is we can expand both of them and compare terms. What does that mean, you ask? Well, let's do it, and you will see. So I'm very literally going to start with my given formula function, and I'm going to expand it. And I'm going to do the same thing for the second one. Okay, now you might be wondering why I did that step with the x term, but I'm going to show you in a second. So what you'll notice is that we have three distinct sets of terms. We have what we call our x squared terms. Then we have our x terms. So these are terms multiplied by x. And then we have our constant terms that don't contain x at all. And what we're literally going to do at this time is we are going to compare the terms of our expansions, meaning we are going to compare our x squared terms to each other. We're going to compare our x terms to each other. And we're going to compare our constant terms to each other. So let's do that in turn. Okay. So from the first set, I can see from my x squared set of terms, I can see that a and 3 need to be equal. So this is our first one, and it's pretty straightforward that I know that a has to be 3 in order for ax squared to be equal to 3x squared. Let's look at our x terms now. So if I equate the things in green here, I'm going to see that 10a, oops, I don't need the x, 10a equals negative 3b minus 6. But we know what a is. We already found it. All right, so we know our b term. Okay, and lastly, we're going to look at our constant term. So here we have lastly, we're going to look at our constant term. Okay, so we've got 25a plus c equals 6b. We know that a is 3. Okay, so that is the first method of figuring out what a, b, and c are when I have, or any parameters, any letters, in fact, when we're given two versions of the same parabola. So in my next method, the next method is a bit more graphically intuitive. So what I mean by that, so we're going to call method 2. Reasoning with graphs. Okay, we are still going to start by jotting down our two forms. And I think it is still pretty obvious that A has to be 3. And the reason for that is if I were to expand either one of these two forms, I know that my first coefficient here is going to be ax squared plus some other terms, and this one's going to be 3x squared plus other terms. A has to be 3. So now, what I'd like us to do is graph what we know based on these two different representations. So for example, I know that because there's a -5 here, I know that my axis of symmetry is at x equals 5. From this piece of information, I know that my x-intercept, one of my x-intercepts, is at 2, 0. So I'm going to put that here. Okay, so I know this is 2, 0. And since 2, 0 is 3 units away from x equals 5, I know my next x-intercept has to be 3 units away also from x equals 5. So that tells me that my other x-intercept is at 8, 0, which means, therefore, that b equals 8. Okay, so we actually know all the parameters of this form of the parabola, which describes our given parabola. We just fully know this form. We just don't know the vertex form completely because we still need to find C. Now, I know it's a different letter, but if we compare this to our formula that we already know, if we compare it to y equals ax minus h squared plus k, we can see pretty clearly that this c value is actually, it's the y value of the vertex. It's yv. Okay, so how do we go about finding yv? Well, I can find yv if I know what xv is, just by subbing xv into my equation. Do I know what xv is? Well, I do. It's 5. So in order to find yv, all I have to do is sub 5 in here. Okay, so there you have it. You have the two different methods for solving this problem. What I would recommend you do is kind of understand both, but you can pick one and just use it when whenever I ask you a question like this.